Okay, number 6 on your homework sheet, projectiles fired at an angle. A ball is thrown to the catcher from left field, a distance of 80 meters. The average horizontal velocity component is 20 meters per second. What is the maximum height reached? So you have to assume that it's caught at the same height that it's thrown at, because it doesn't tell you anything otherwise. So you have to assume that it's a ground-to-ground. And it says that its average horizontal component, so its VIX, is 20 meters per second. And it says that it's thrown a distance of 80 meters. And it wants to know what's the delta dy max. Okay, so if we set up our x and y's, our x here, our VIX, is 20 meters per second. Our AX is 0. And our delta dx is 80 meters. In the y direction, we don't know VIY. We know AY is 9.81 meters per second squared. And we're looking for delta dy max. Okay? If you look here, we can find our time. It'll be our full time. And then once we get that, we'll have our half time over here. So we can find our VIY and then our delta dy max. So starting in the x direction, delta dx is equal to VIX delta t 1/2 AX delta t squared. And this will go to 0. And so delta t will equal delta dx over VIX. So 80 meters divided by 20 meters per second. So our time is 4 seconds. Which means then in our y direction, if we look at up, AY is equal to VFY minus VIY over delta TU. This goes to 0. And so we can solve for our VIY. Bring over the negative, bring over the TU. So negative AY delta TU. So VIY is equal to negative, this was down, negative 9.81 meters per second squared, and our half time will be 2 seconds. So VIY will be equal to positive 19.62 meters. Okay, so then once we have that, we can find our delta dy max. And remember, for our delta dy max, we have to use the time up. So the TU, A delta TU squared. So delta dy, and this is max, of course, is equal to 19.62 meters per second times 2 seconds plus 1/2 negative 9.81 meters per second squared times 2 seconds squared. So delta dy max is going to equal, what is that, 39.24 meters minus 2 squared is 4, half of 4 is 2, minus 19.62 meters, and we get our delta dy max to be 19.62 meters. Okay? Done. All right, and then the other question on that sheet I asked you to do was number 7, and there's no way I'm going to end up and put it on the bottom of that page. Skip over. And number 7's a ground-to-ground, okay? So it says, shot from the edge of a roof of a building that is 50 meters high. So this is 50 meters. It's shot at an angle. It goes up. It comes down. Okay? The muzzle velocity, so the VI is 80 meters per second, and the angle of theta is 40 degrees. So in the x direction, well, the VIX is VI cos theta, and the y, VIY, is VI sine theta, up. AY, 9.81 meters per second squared, down. AX The question wants the distance from the base of the cliff, delta dx, which we don't know. We also don't know the time. And it tells us 50 meters high, so the delta dy is 50 meters, and it ends up below where it started. So it's 50 meters down. We also don't know the time. And in the last part of the question, we want VF, but we'll get to that later. So first we're going to start in the y direction and find our time. So delta dy is equal to VIY delta t 1/2 AY delta t squared. Okay, and it's going to be a quadratic. Just watch as you put your negatives in. So the delta dy will be 50 meters. The VIY will be 80 meters per second sine of 40 delta t plus 1/2 negative 9.81 meters per second squared delta t squared. And I'd fill my things in here before rearranging so I don't lose my negatives. So now I take these guys over, so my delta t squared term becomes positive 4.905 meters per second squared delta t squared. And this term will become negative 80 meters per second sine of 40 delta t, and then minus 50 because I haven't changed that side. Okay, so I have my A, my B, and my C. My B and my C are both negatives. So then delta t will equal minus B, so negative, negative, so this becomes positive. 80 meters per second sine of 40, plus or minus the square root. No way I'm going to have enough room here. Let's just take it down here. Sorry about that. So delta t will equal 80 meters per second sine of 40 plus or minus the square root b squared, so negative 80 meters per second sine of 40 squared minus 4a, 4.905 meters per second squared, c, negative 50. And then all of it is over 2a, so 2 times 4.905 meters per second squared. So I didn't change my 80 sine 40 just because I knew it wasn't going to be pretty, but if I do it now, I get 51. So delta t is equal to 51.423, and then there's a bunch of zeros, so we'll stop there. Meters per second plus, and then that's squared. So 51.423 squared inside the root will be 2644.3258, etc. Meters squared per second squared. Minus and a minus will be positive, so it'll end up being plus 4 times 50 is 200 times 4.905. So 100, oh, I could have done that in my head, 981 meters squared per second squared. And of course on the bottom will be 9.81 meters per second squared. And so we'll have delta t is equal to 51.423 meters per second plus or minus. So add these guys together, 362533 meters squared per second squared over 981. So delta t is equal to 51.523 plus over 9.81 meters per second, and delta t is equal to 51.5, etc. minus. Oops, and this is meters per second. Sorry, so when we take the square root, we get 60.21 meters per second. Obviously, this one's going to give us a negative, so I'm going to save time because we're running out of it on the video. So add that to our 50, divide by 9.81, and you get 11.37958 seconds. Once you have that, what does the question ask? The distance. So